really just touching the very basics of statistics. We're not going in depth at all. So if you took a full statistics class, it would actually cover some of the probability that we've already done, and then start moving into this stuff. Okay, lots of vocabulary in this section. Statistics is the science of data. This involves collecting, classifying, summarizing, organizing, analyzing, and interpreting numerical information. So if you have your handout today, your fill in the blanks are statistics, science, classifying, and interpreting. There are two types of statistics, descriptive statistics and inferential statistics. So descriptive uses numerical and graphical methods to look for patterns in a data set, to summarize the information revealed in the data set, and to present that information in a convenient form. Inferential statistics utilizes sample data to make estimates, decisions, predictions, or other generalizations about a larger set of data. So one of them is just used to describe what you found, and then the other one takes what you found and uses it to predict what might happen in the future. Okay, that's the difference between the two. A population consists of all elements whose characteristics are being studied, and a sample is a portion of the population selected for study. Most of the time, the population that you want to learn about is too big to get information from every single item in that population. So instead, you take a sample and use the information from just a select amount of items or people to find out that information. A random sample is a sample obtained in such a way that every element in the population has an equal chance of being selected for the sample. So ideally, you want to have a random sample. You want your information to be as accurate as possible, meaning that if you have given everybody or every item an opportunity to be selected, then there's a chance that you'll get information about each of the different areas that you're looking for. So if you want to select a random sample of a large city to decide how the city's citizens feel about casino gambling, okay, this would be an example. We might randomly select neighborhoods of the city and then randomly survey people within the selected neighborhoods. Now, if we only select specific neighborhoods or the first 200 people we find in the telephone directory, then not everyone has an equal chance of being selected. So if we pick the first 200 people in the telephone directory, would I even have a shot at being selected? Having a last name that starts with S? Probably not. Okay? So the best way is to figure out, lots of times in these studies, computers generate, where you're going or what you're, or who you're going to be using. If you don't have a computer, you do the best thing that you can, put items in a hat and pull them out, randomly and so on. So sometimes if people are involved, the information is sealed in an envelope and you have no idea, who you're given, every person has a number and you had no idea who these people are when you're conducting the study, so that it's completely random. Some of your homework questions are going to ask you which are the best random samples, and they'll give you an example of what you're looking for. And so you're trying to make sure that every item has an equal chance of being selected. That's what you're looking for. Okay, so an element of a sample or a population is a specific subject or object about which the information is collected. That could involve a person if you're looking at a population of people, a firm, maybe you're looking at all the law firms in St. Lucie County, and so one firm would be an element. An item, a state if you're studying the 50 states, or a country if you're studying a population of countries. A variable is a characteristic under study that assumes different values for different elements. So it's just something in particular that you want to learn more about. That's the variable. Okay, so on your handout, if you have a handout, you have this flow chart. And the intention of the flow chart is just to write the headings that are going to appear here. There's like some more detail, but you might not have room in the bubbles to write all this information down. And we will touch on each of these variables in more detail after the flow chart. So a variable can be broken up into two different types, quantitative and qualitative. So you don't necessarily have to write what's in parentheses in your bubble there, because we're going to talk about that more. But qualitative can also be known as categorical. And then quantitative variables can be split up into two types. So again, only write down the headings, discrete and continuous. So the part in parentheses we're going to touch a little bit more in a second. Okay, so let's first take a look at quantitative variables. These are numerical variables, something that you can put a quantity to. Okay, hence the word quantitative. So a discrete variable consists of a countable value and can assume only certain values with no intermediate values. So of the two quantitative variables, one of them was discrete. So these are things that you can count. Now, if I were to count the number of students in here, I wouldn't end up with 25 and a half, right? It would be a countable number. It would end up on an integer value. So, maybe 26 students or whatever we'd end up at. So so 25 and a half would be that intermediate value. Discrete variables do not have those intermediate values. It's what you can count. So some of the examples in the parentheses earlier were number of houses, number of accidents. And so you can write down, a couple of those examples under there. Number of people under that heading there. A continuous variable can assume any numerical value over a certain interval or intervals. So, in other words, continuous is still a numerical value, but it can have intermediate values. For example, time. If we were looking at time in hours, you could say 1.5 hours have passed, or 1.25 hours have passed. A lot of different ways you can do that. If you're measuring the length of a piece of wood, it could be 3 feet, it could be 3 feet 4 inches, it could be 3 1/3 inches. Okay, a lot of different ways that you could express that. So these would all be continuous variables. So the examples I gave you so far were time and length. And then the other type of variable we have is a qualitative or categorical. This is a variable that cannot assume a numerical value, but can be classified into 2 or more non-numeric categories. One of the examples in those parentheses in the bubbles was make of a car. Okay, you wouldn't say 5. Okay, you would give it an actual name, a category. It could be hair color. So these are the types of qualitative variables. Okay, let's do a little bit of an exercise here of collecting data. And so I would like 10 volunteers to just tell me name, number, siblings, height, and eye color. So Sean, are you volunteering?
Yes.
Okay, go ahead and shout out the answers.
2 siblings, 5'9". Green.
Okay. Okay, so we have 10 students from our population of our class. So these 10 students would be a sample of the class. Was that necessarily a random sample?
Was it random within the population?
Yeah, was that a random sample that I just took?
Was it volunteer?
Okay, so not exactly random, because not everybody in the class had an equal chance of being selected, because I didn't force everybody to be a part of it and pull your name out of, So you had to actually speak in order to be selected. And there were some people that were not going to speak out loud in this class, okay? So, so it was, you know, somewhat random, but not the perfect random sample that we're talking about. All right, so we collected 3 different items, and so these were 3 different kinds of variables that we collected. Raise your hand if you can tell me specifically what the first one was. What type of variable was that? It's a discrete variable. Good. Okay, so the first one, I did not want to go back to that. Hold on. Okay, so the first one was a discrete variable. Okay, number of siblings. Remember, it is a quantitative variable, but I said be specific as possible, which means it's the countable variable. All right, next one. Who wants to take a stab at that one? Carol?
Qualitative.
Nope, next one's not qualitative. Who said it over here? Okay, continuous is correct. Okay, it's still a quantitative variable because it's about numbers, but it is continuous because it's not, you know, it's not a counting number. It could be an intermediate value. Okay, who wants to guess at the last one? Carol?
Quantitative.
Not quantitative.
Categorical.
Yeah, categorical or qualitative, right.
That's what I'm saying.
Yeah, so qualitative or categorical, right, because this one was not about naming an amount. It was about naming a quality or a category. Okay, now, once you've gathered your data, as we have here, then there's a lot of different ways that we can represent this information. And so the first thing, if it's depending on what you're looking at, you can determine the class in one of the categories into which qualitative data can be classified. The class frequency is the number of observations in that data set falling in a particular class. Okay, so if we have qualitative data, which one of those characteristics was qualitative, the ones we just looked at? Eye color. And so the class would be the different categories that we had or the different colors. So the ones that we had were green, brown, and blue. Those are the ones that were mentioned in that sample. And then the frequency would be how many times there was a person with green eyes or how many people had brown eyes or something like that. Okay, so the first thing that we can represent them in is in a frequency distribution. So if you are asked to create a frequency distribution, it means you're creating this table of information. So you have eye color, and so like I mentioned, the answers that were given were green, brown, and blue. And then we could tally up the information that we get as it comes. Now, the tally column is most helpful when there is a lot of information that you're looking at. We only had 10. We probably didn't need to tally them. We could just count them. So you won't always find a tally column when you're doing a frequency distribution. It's just there as an extra help. Okay, but as I go down the list, okay, I had 2 green. I had 1, 2, 3, 4, 5, and 5. We actually want to count that way, 6, 7. And then 1 blue. And then, so our frequency would be 2, 7, and 1. And then double check to make sure that the frequencies add up to the total number of people that were in that sample. So 2 plus 7 plus 1 does add up to 10. So again, the tally column is up to you, whether you really want to have one or not. That's not necessary. It's just there in case you need it as a help. Okay, once you have a frequency distribution, you can also create visuals of your information. The next one would be a histogram. A histogram is sort of like a bar graph. You guys have seen bar graphs in your homework assignments before. But in a histogram, all of the bars are squeezed together. They're all touching. Okay, that's the difference between a bar graph and a histogram. And so the height would be that frequency that you're looking at. And so, again, here, the last part is that difference. In a histogram, each column shares a side, okay, because they're all touching. So histogram is like a bar graph where they share a side. That's the most important information there about the histogram. All right, so here is a histogram of a previous class that I did a long time ago. And so we had eye colors of brown, blue, green, and hazel. And then the heights show the frequency of each of these categories. So again, just like a bar graph, except all of the bars are squeezed together so that they're touching. So we could make a histogram of the information we collected, but which of these columns would we not need? Hazel. Nobody in our class said that they had hazel eyes, at least in the sample. Okay, so we would eliminate this column. There were 2 green. Instead of having 5 blue, there should have only been 1 blue. And then this brown column would have gone all the way up to the top. Okay, so there's the difference in our histogram for our specific class. Again, you're going to be asked to identify the correct histogram for the data that you have. The other type of visual that you're going to look at is a frequency polygon. This is a line graph, and the axes are labeled exactly like a histogram, so you would have a bar at the bottom, like if we were in algebra, it'd be your x-axis and your y-axis, your horizontal axis and your vertical axis. They would be labeled exactly the same way, but in this case, you would have a line showing those heights. Now, one of the ways that you can make a line graph is if you first make your histogram, then put a point at the midpoint of the top of each rectangle, and then connect each of these midpoints with a straight line. And then finally draw each endpoint down to touch the horizontal axis. Let me go back to that last histogram and illustrate what I'm talking about here in this slide. Okay, so if I go back, let me clear this writing. Okay, so we can put a midpoint at the middle, a point at the midpoint of the top of each bar. So 1 there, 1 there, 1 there, and 1 here. Okay, so once you've done that, now one thing I didn't point out, notice in the histogram that each bar is exactly the same width. And that's actually important in a histogram, okay? Each of the bars have to be the same width. So then when you make the polygon on here, the line graph, your midpoints are, the same distance horizontally apart. So then it's just connect your dots with a straight line. But then the very last step is the ones on the end, take these points down to the corners of that bar. Okay, so this is why it's called a polygon, because notice that if you use the base and then these lines that connect here, you've created this polygon, this closed shape with straight lines. Okay, but you don't want the histogram behind it anymore. So this is what our frequency polygon would look like once you've finished it. Okay, so we have a histogram, we have a frequency polygon. So I want you guys to practice your frequency distribution. So this was the first one, the table. And notice that we have a list of test scores here, and there's a good amount of test scores. And if we list each individual score one at a time, your table could be really long, okay? So instead, what we can do is we can group the items into classes. So this would be different types of classes than what we talked about. It's not a category. Well, in a way, it is a category, but this is a numerical category. So in other words, we could, since our lowest score is 43 and our highest is in the 90s, we can group them by tens and start with the 40s. So at the top we would have 40 through 49, those would be the 40s. And then the next class could be 50 through 59, and then 60 through 69, and so on. So if you have your handout, then you have a frequency distribution chart that's blank in there. So you can fill it in like this with your test scores. So starting at the top, 40 to 49, and then 50 to 59, 60 to 69, and so on till you get to the 90s. Now notice that in this table I did not put a column for a tally, but if you'd like to add a column for a tally, then go ahead and do that. That's up to you. That's whatever you need to do to create your frequency distribution. So if you want the second column to be tally and then just add a third column for your frequency, then that's fine. Okay, so I'll give you a second to finish writing those tens in there. I know you have your handout with you, so I'm going to put it back to the other screen so that you can actually create your frequency distribution. All right, so take a look at this information and start counting how many in each of the groups of tens that you have. And, you know, there's lots of different ways that you can do this. If you have your handout, that's the best way, because you can say, okay, let me go across and say I've got a 47, so there's 140. Okay, and then here's another one here and another one here. And then I think those are all the 40s. Anybody see any more? Okay, so then if you have different colors with you, you can use one color for the 40s and then skip. If you don't have different colors, well, here's another thing you can do. Notice that I slashed it from right to left on the 40s. Well, maybe if I go from left to right for the 50s to make it easier to count, and then maybe the 60s I'll circle, and maybe the 70s I'll put a box around. Okay, whatever you have to do to make sure that you don't miss the information. So especially when you're working in Math Excel, you might need to write out your numbers on paper to make sure that you don't miss any information. So I'll give you a couple minutes to finish your frequency distribution. Now remember, as you're finishing up, it'd be good to know how many total you have. And that's not too hard to look at, especially when the information's very symmetrically written. There's 8 columns of scores and 5 rows. So how many total scores are here? 40, good, 8 times 5. Okay, so make sure that the numbers in your frequency add up to 40 to make sure you didn't miss one, or you didn't come up short or something like that. Okay, 3, and then the 50s, 6, 60s, another 6, 70s, 11 in the 80s, 9, and the 90s, 5. Okay, add those up. Does that add up to 40? Yes. Okay, good. Okay, it does add up to 40, so that's your check to make sure that you have all the numbers in there. Okay, once you have created your frequency distribution, there's a couple characteristics that we can look at this table. All right, so first of all, the lower class limit is the leftmost number in each class. Now, when you look at these classes, the very top one is the first class, the next is the second, the third, fourth class, until you get to the bottom. How many total classes do we have in this table? 6. There are 6 classes. So what would the lower class limit be in the third class? 60 is correct. So third class would be 40s, 50s, 60s. Okay, the lower class limit is the lowest number in that class, so 60. All right, the leftmost number in that class, as opposed to the upper class limit, which is the rightmost number in each class. So what is the upper class limit of the fifth class? What did you say? 89 is correct. Good, because fifth class, 40, 50, 60, 70, 80. And then 89 is the rightmost number in that class, or the highest number in that class. The class width is the difference between two consecutive lower class limits. So look at two consecutive lower class limits and subtract. Okay, I heard 10. That's correct, because for example, 50 minus 40 is 10. So consecutive lower class limits mean two lower class limits from classes that are right next to each other, okay, consecutive. You could also have picked 70 minus 60, and that's also 10. So in some of your homework, you're going to be given a frequency distribution that's already done for you, and you have to be able to identify these items from the frequency distribution. Now, when you are creating a frequency distribution from scratch, the first thing you will do is determine what the class width would be. And if you notice, I did that for you. I said, you know what, we have test scores. Let's go ahead and group our numbers into tens. That's the first thing I said before we created our frequency distribution. So if you're going to create it from scratch, you want to decide on that first before you create your table. We could have done it by fives. Now, we could have listed our numbers individually and had a class width of 1. But again, that means that that chart would have been really long, going from 43 all the way down to 99 or whatever it was. So the best thing to do is to group your numbers appropriately to have a nice chart, and that gives you a good, gives you enough information in that chart. Okay, so the class width for this one is 10. Okay, so we're taking a look at 12.1. And you'll notice that the first type of question is what type, which one would be the best random sample? Here, let's see if that's big enough. Okay. The government of a large city needs to determine whether the city's residents will support the repair of several roads. The government decides to conduct a survey of a sample of the city's residents. Which one of the following procedures would be the most appropriate for obtaining a sample of the city's residents? Choice 1 is a survey of random sample of the residents who use public transportation. Choice 2 is a survey of every third person who walks into the local grocery store. Choice 3 is a survey of the last 100 residents listed in the telephone directory. And choice 4 is a survey of random sample of persons within each geographical region of the city. Okay, so choice 1, 2, 3, or 4, which one would be the best sample to choose for this study? Okay, I see a majority of 4. Excellent. Okay, notice that there were 2 answers that said random sample, but the first one, what was the problem? Only those that use public transportation, and they're talking about repairing several roads. Okay, so I'm sure the people on the bus would want nice roads, okay, or maybe they don't care, but you wouldn't hit anybody that drives their own car. Okay, and they're talking about getting whether the city's residents will support it. So not every resident has an equal chance of being selected if it's only those using public transportation. A questionnaire was given to students. The first question asked, how stressed have you been in the last week on a scale of 0 to 10, with 0 being not stressed at all and 10 being as stressed as possible? The responses are shown to the right. Okay, so the first column is the category. It's the class, the stress rating that they gave. Okay? And then the second column is the frequency, how many students actually gave that stress rating. So, which stress rating describes the greatest number of students? Okay, 7. So you type the number 7 in. Fantastic. Okay, that was correct, because when you look at the row for 7, this one had 32 students that said they were stressed at a level of 7. And notice that, all of the other frequencies were lower than that. So that's what you're looking for that. How many students responded with this rating? 32. Excellent. Okay, if they ask you to create a frequency distribution, they're going to ask you to fill in the numbers one row at a time. So it's up to you if you want to do one row at a time like this, or if you want to just create the entire table on your paper first and then fill in your numbers. Okay, whatever you feel most comfortable with. Notice that their frequency distribution is just going to be one number on the left. So just how many people said that they spend 15 hours in the week on homework. So you figure out how many people said 15. Then it would go to the next number and then the next number, and you fill it in. So just to give you a heads up of how your problems are going to look. Okay, here's another frequency distribution with the number of social interactions students had during the week. So they were supposed to keep a chart and make note of that. And so either they had 20 to 24 social interactions, or 25 to 29 social interactions, 30 to 34 social interactions, and so on. And for this problem, they want you to identify the lower limit of the fifth class. Okay, 40 is what I heard, because you're going to 1, 2, 3, 4, 5, so there's the fifth class. And the lower limit is that number on the left, 40. Okay, hopefully some of these problems will be pretty straightforward. Fantastic. The ones that may not be as straightforward, let me see if I can find one here. Okay, again, social interactions, all the numbers changed. It says how many students had at least 35 social interactions for the week? How many students had at least 35 social interactions for the week? Somebody raise their hand. Yes, Jordan. Okay, so what did you say, 15? All right, and which numbers did you use to?
All the numbers from the category 35.
Okay, so all of the numbers from this class of 35 to 39 down, because remember the words at least 35 means 35 or more. So all of these people right here had 35 or more. And so adding these up, you said you got 15? Okay. So let's see if you are correct. Well done. Okay, so again, look for keywords like at least, at most. At most means that it's that many or less. Exactly. Words like that you want to pay attention to make sure that you are, getting the right numbers. All right, if it asks you to create a histogram then that's going to be more of a multiple choice problem here. And so they gave you a chart. Notice that this frequency distribution goes horizontally instead of vertically. So you could have it either way. It could go, down the column, or it could go across the rows. So notice they labeled their social interactions A, B, C, D, E, F so that they didn't have to write as much information when they wrote a histogram. So you have to pay attention to the frequency of each of those classes, and then the heights should match the frequency, and so on. Sometimes you can eliminate some right off the bat. Look at this one. J has it all the way up almost to 20, and if you look at J over here, there's only supposed to be 2. Okay, so use that information to eliminate. Okay, bottom right looks like what you should have. Okay, well done. So then next you have to find your frequency polygon. Notice these are sort of small. So the magnifying glass, you can click on that and it will make it much bigger so that you can look at it, look at each of the heights better. So A, B, C, D, E, F, G, H, I, J. And so that's your last one here. Is that a 2? No, so that's not it, okay? And then eliminate the ones that are not right and then, look for the ones that are. The last type of visual that I want to look at before we move on. By the way, they're also going to give you a frequency polygon or something like that, or a histogram, and ask you questions about it to make sure that you can interpret these correctly. But I want to move on to our stem and leaf plot. Okay, so it says a random sample of 40 college professors is selected from all professors at a university. The following list gives their ages, and you need to construct a stem and leaf plot for the data. Okay, so notice that they've already created this table. It says stem and leaves. In a stem and leaf plot, it's a way to organize your information where you can actually still see the exact numbers in your list, but it's a shorthand, if you will. So the stems would be the tens digit of the number, and the leaves would be the ones digit. Okay, so I'm going to create my own stem and leaf plot off to the side here. And so looking at our numbers, we want to figure out what's the lowest tens digit that we see. And it appears to be 20s, and I'm going to cheat a little bit by looking at what they've started with here. Okay, so the 20s. So identifying all the numbers in the 20s, we have one here, 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 and there. Did I miss any? I know it's sort of small for you guys. Okay, so we have a 21, two 24s, and a 27. Now, in some stem and leaf plots, it would be helpful to put your numbers in order, in numerical order, ascending order. I don't think that MathExcel cares as long as you separate each of the numbers with commas. In a pure stem and leaf plot, you wouldn't use commas. You would just evenly separate your ones digits side by side. So if I put them in numerical order, I'm going to have a 1, a 4, I have another 4, and a 7. Okay, so this represents 21, 24, 24, and 27. So I can clearly see that there were 4 numbers in the 20s there. Okay, now I'm going to move on to the 30s. So let me erase what I've done so far. And again, sometimes, like I've taught you guys in other chapters, if you write down your numbers in pen and then use a pencil when you're organizing, that way you can erase lightly and still have all of your information there. So now for the 30s, I've got one here, 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 here. Okay, I think I got them all. So we've got 30s, couple 30s, 31, 32, 33s, 36, 37s, and an 8. So we have a 30, so I'm going to put a 0. I have two 30s, so another 0. And I'm trying to line them up vertically when I space them evenly. And then I've got 131, 132, two 33s, no 34, 35, we're going to 36 next, right? Two 37s, and a 38. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, that matches. Okay, so there are my 30s. And then next we would move on to our 40s and so on. Does this make sense for what you're looking at? The really neat thing about a stem and leaf plot is when you draw it up, if you, you can tell exactly how many numbers you have in each, and you still know exactly the numbers that are in there. Now the other thing is that let's say that I make columns out of these, and then whatever my 40s and 50s and so on would be. Okay, if I make a bar at the end of each of my rows, if you turn it sideways, you would actually see what the histogram should look like if you were to draw it as a histogram. So again, the stem and leaf plot is sort of neat because you still have all of your information there, but it's in a nice organized way for you to write it. Now, even when you're creating your distributions or making your histograms or whatever, if you want to, instead of writing out all the numbers on your paper, you could just write it out as a stem and leaf plot. It'll take less time and, chart it out that way. Whatever is helpful for you. Okay, so we had 1447 here, so this is how you would type that in. Let me just double check that the order doesn't matter. So we could do 1, 7, 4, 4. Okay. No, and it actually accepted it. Okay, so again, make sure mine did not say, the directions here did not say that order was important, but maybe on a different problem it might say order is important. So be paying attention to that information. And then next, 0, 0, and so on. So you would finish your problems that way.